Welcome to this comprehensive guide on setting up your Tazama development environment. I'm going to walk you through every step you need to start developing and testing Tazama rule processors. Whether you're contributing to the open source project or customizing Tazama for your organization, this tutorial will get you up and running. Before we dive in, let's talk about what we're building here. We'll be setting up a local development environment that connects to a Tazama server infrastructure. Think of it this way. The heavy lifting services run on a server somewhere, and you'll develop and test your code locally on your own machine while staying connected to that infrastructure. This tutorial focuses on the installation from the perspective of a Windows user. If you need help with the installation on a different operating system, you can check in with our Tazama community on Slack. In this tutorial, we're going to be working our way through this guide we had created in our GitHub to help developers set up their environments. You can find this guide here on our Tazama-LF GitHub organization in the Docs repository. Inside the Docs repository, you will see a Guides folder, and inside it, this document called Dev Setup Environment. You'll also find a link to the document in the description below this tutorial video. Let's start with the basics. First, you'll need a code editor. We're using Visual Studio Code for this tutorial, but feel free to use Eclipse, Sublime Text, or whatever you're comfortable with. You can follow this link to head over to the VS Code website and download the installer. Once downloaded, run the installer. We're using the default installation options to keep things simple. No extra plugins are needed right now. We install VS Code first because both Node.js and Git have installation options that integrate with it. Next up is Node.js and NPM. Navigate to nodejs.org and download the installer for your operating system. Once downloaded, run the installer. During installation, we recommend selecting the option to automatically install additional tools. This includes Chocolatey, Python, and various development tools that'll make your life easier down the road. Run through the installation wizard. This might take a few minutes, especially if you're installing those additional tools. Don't worry if it seems like it's taking a long time, that's normal. Now let's install Git. Follow this link to the Git website and download the installer, and once downloaded, run it. During Git installation, make a few specific choices. Select Visual Studio Code as your default editor. Choose Checkout as is, Commit as is for line endings, and use Windows default console window. For everything else, the defaults will be fine for now. Next, we need Postman for testing our microservices. Follow this link to the Postman website and grab the application for your system. Tazama uses Postman collections extensively, both for testing and for updating system configurations. You'll need to create a free Postman account to import the Tazama test collections. Finally, Docker. Now, this is optional if you already have access to a persistent development server running Tazama. But if you want to run everything locally, you'll need Docker Desktop. For this tutorial, we're assuming you have Tazama running on a separate server. So we're going to skip the instructions for installing Docker Desktop. All right. Now that we have all our tools installed, let's set up authentication with GitHub. We're going to create a personal access token. This lets you interact with Tazama repositories seamlessly without constant authentication prompts. Log into your GitHub account and click your profile picture in the top right corner. Navigate to Settings, then Developer Settings, then Personal Access Tokens, and finally, Tokens Classic. Click Generate New Token and select Generate New Token Classic. By the way, if you're planning to contribute to Tazama, you'll be required to set up two-factor authentication on your account to help keep our community safe. If you have 2FA enabled, you'll also need to authenticate yourself to create a PAT. Give your token a descriptive name, maybe Tazama Development or something similar. Now here's the important part. You need to select specific scopes. Check the boxes for workflow, write packages, and read organization. These permissions are essential for working with Tazama repositories. Scroll down and click Generate Token. Once the token generated, copy that token immediately. GitHub won't show it to you again once you leave this page. Keep it secret, keep it safe, and certainly don't expose it on a YouTube video like this. I'll be deleting this token as soon as this video is done. Now we need to set this token as an environment variable on our system. The process differs depending on your operating system, but I'll walk you through Windows. The easiest way to do this is to select your search bar here at the bottom of the screen and type ENV. The application to edit the system environment variables should show up here at the top. Click it to open the application. Then click the Environment Variables button at the bottom. Under User Variables or System Variables, click New. For the variable name, enter exactly GH_token. That's what the Tazama scripts are looking for. For the value, paste in your GitHub token. Click OK all the way back to save everything. If you haven't yet set up Tazama to run as a server, now's the time. We're not going to go into the detail of a Tazama full-stack deployment in this tutorial, but you can navigate to the full-stack Docker Tazama repository to read the documentation and follow the steps there to guide you through the deployment of a standalone Tazama system. We will, however, briefly highlight the way you should be deploying Tazama to provide the infrastructure required in this tutorial. Let's remote into our Tazama server quickly and take a look. The Tazama full-stack deployment is governed by a handy batch or shell script that helps to guide you through the setup process. If you've run the script, you'll see this menu of options. For this tutorial, and especially if you're just starting out, select Option 2, Public Docker Hub Deployment. This option deploys all the core infrastructure services plus 2 sample rule processors, Rule 901 and Rule 902. After selecting Option 2, you will be able to select some additional optional components on the next menu. Some of these are defaulted already, but for our tutorial, we really want to select this option here to enable the Tazama NATS Utilities application. The NATS Utilities module is particularly useful for development in Tazama. It provides a REST API proxy that lets you interact directly with internal processors, making testing much easier. We'll use this later for testing our rule processor. There's also Keycloak for authentication, various relay services for downstream integrations, basic logging, and a demo UI for exploring Tazama visually. You can deploy these if you need them, but they're not required for what we're doing today. The deployment process will pull down Docker images and start up the Tazama containers. Grab a coffee. This might take several minutes depending on your internet connection and system resources. You'll see a lot of output scrolling by. Don't worry, that's normal. We're going to cheat a bit here. We'd already pulled down all our containers manually before recording the video, so our deployment completes pretty quickly. And it's done. Once complete, you should have a fully functional Tazama instance running. You can verify this in Docker Desktop by checking that all the containers are running with green status indicators. Let's get back to our local machine. Now, let's set up a Tazama processor on your local machine. We're going to use Rule 901 as our example because it demonstrates all the key concepts you'll need. Before we continue, let's take a moment to understand how Tazama rule processors work. Each rule processor actually consists of two parts, the rule module and the rule executor. The rule module contains the rule-specific code, mainly a database query that looks for suspicious patterns in historical transaction data. The rule executor is a standard wrapper that handles all the infrastructure overhead, connecting to NATs in the database, logging, error handling, and so on. Think of it like this. The rule module is your custom business logic, and the rule executor is the standardized container that makes it work within Tazama's architecture. When we deploy a rule processor, we actually bake the rule module as an NPM package into the rule executor. Okay, less theory, more practice. Let's build a rule module. Open a command prompt and navigate to the folder where you want to store your code. I usually just navigate to the folder inside the Windows Explorer and then run a command prompt from within that folder. Like this. I'm working from the dev folder on my C drive, but you can use whatever location makes sense for you. In your chosen folder in the Windows command prompt, type git clone https://github.com/tazama-lf/rule-901. This downloads the Rule 901 repository to your local machine. Once that's complete, navigate into the new folder with cd, Rule 901. Now, before you do anything else, and this is really important, you need to create a new code branch. Never work directly on the main or dev branches. Type git checkout -b, and then give your branch a name. We usually prefix branch names with our organization name, so I might create Tazama/my feature name. You should use something like your org/your feature name. Keep it short but descriptive and use dashes instead of spaces. Let's prepare this rule module for development. First, we'll clean up any existing build artifacts. Type npm run clean. If this is your first time running a clean, npm might prompt you to install rimraf. Say yes, it's needed to clean up the build folders. Next, install all the dependencies. Type npm install. This downloads all the packages that Rule 901 needs to function. You'll see a bunch of output as npm works its magic. Finally, build the application by typing npm run build. This compiles the TypeScript code into JavaScript and creates a new lib or build folder in your repository. Okay, so now we need to set up the rule executor. Navigate back up one level from your Rule 901 folder by typing cd ... The first few steps are identical to the steps for preparing Rule 901, so we'll go through those quickly. Clone the rule executor repository with git clone. Navigate into that folder with cd rule executor. Create a new branch here too with git checkout -b and a description. And clean the repository with npm run clean. Now here's where things get interesting. Normally, the rule modules are published to the Tazama GitHub package registry as npm packages. The rule executor would then import the published package. But since we're developing locally, we want the rule executor to use our local copy of Rule 901, not the published version. From the Rule Executor folder, launch Visual Studio Code by typing code dot. The dot tells VS Code to open the current folder. Once VS Code opens, find the package.json file in the File Explorer on the left and click it. Scroll down to the Dependencies section. You'll see a line that says Rule with a reference to the published NPM package. We need to change this. Replace that line so it reads like this line in the documentation. In fact, you can just copy this line and replace the one in the package.json file. This tells the rule executor to look for the rule module in your local file system in a folder called Rule 901 at the same level as your rule executor folder. Make sure that path matches where you actually cloned Rule 901. Save the file. You can press Ctrl S or use the File menu. Back in your command prompt, you can now install the dependencies with npm install. This will take a moment. What's happening here is npm is installing all the dependencies for the rule executor from the npm package registry on the internet, as well as the Rule 901 module on your local machine. Let's arrange these windows a bit. To verify that the Rule 901 package was correctly imported, you can type npm list rule. You should see this output showing that the rule module is coming from your local Rule 901 folder, not from the npm registry. That's exactly what we want. Now we need to configure the rule processor. Each Tazama processor uses environment variables stored in a .env file. Your cloned repository doesn't have one yet. We can create it from the .env.template file in the rule executor folder. But for this tutorial, we're going to take a shortcut. Instead of manually filling in all the configuration values from scratch, we'll use the pre-configured .env file that was used to deploy Rule 901 on your server. Open your browser and navigate to the full-stack Docker Tazama repository. Make sure you're on the same branch you cloned. This will be the dev branch by default. Click into the env folder here and open the rule901.env file. Select and copy the entire contents of this file. Back in VS Code, click this icon at the top to create a new file in your rule executor folder and name it .env. It should automatically open, but if not, click the new .env file you just created to open it. Then, paste in those contents you copied. Now here's the key change we need to make. In Docker, services communicate through container names like Postgres or NATs. But we're running on a different computer than the server, so we need to use the IP address of the server and the ports of the containers instead. Find out the IP address of your server, assuming you're running it on a different machine. I'll wait while you do that. Maybe pause this video until you get back. Got the IP address? Great. Now in the .env file, we need to update several connection strings. Let me walk you through each one. Find each of these database host environment variables here and replace Postgres with your server IP address. And then find each of the database port environment variables and capture the container's outward-facing port number here. It should be 15432. That takes care of the database access details. Now, we also need to update the NATS access information right here at the bottom of the file. Replace NATS here with your server IP address and add a 1 here in front of the 4222. Save the file. These changes now point your local rule processor to the infrastructure running on your server. We're almost ready to run. Build the rule executor with npm run build. This compiles everything and prepares the rule processor for execution. Drumroll, please. Oh no, wait, we got a little ahead of ourselves. Before we run this local rule 901 processor, it's probably best if we first stop the rule 901 processor that is currently running on the server. You don't want two instances of the same processor running simultaneously. They'll compete for messages. If you have Docker Desktop installed on your server, you can stop the container from the GUI. Otherwise, on your server's command line, type docker container stop Tazama-rule-901-1, which is the default name for the Rule 901 container on the server. Okay, now, back on your local machine? Drumroll, please. In the rule executor folder, it's time for the moment of truth. Type npm run. Start. Your rule processor should start up and you'll see initialization messages scrolling by. Look for messages indicating that it's connected to NATs and subscribed to the appropriate topics. If you see those, you're golden. The processor is now running and connected to your server infrastructure. The processor will keep running in this window until you stop it with Control-C. Let's verify that everything works by sending a test transaction. If you haven't already, clone the Tazama Postman repository now. We'll need to open a new command prompt because our previous one is busy running the rule processor. In your development folder, run your git clone command to fetch the Postman source from github.com/tazama-lf/postman to your local machine. Open Postman. We're assuming here that you've gone through the effort of creating an account and signing in already. Let's arrange these windows a bit. Open the Postman folder on the right here. Drag and drop the Postman test collections numbered 2.1 and 2.2 into the Collections tab in Postman, like this. 2.1 is an end-to-end test for your public Docker Hub deployment. And 2.2 is a collection of rule-specific tests that can be used to test Rule 901 in isolation via the NATS utilities. You'll also need to import the Tazama environment file from the Environments folder. Switch to the Environments tab in Postman, and then drag and drop the Tazama Docker Compose JSON file from the Environments folder in the Postman repository to the Environments tab in Postman. Now, critically important, you need to edit this environment file to point Postman to your server. Click on the Tazama Docker Compose environment file here in the Postman Environments tab to display its contents. Go through each variable and replace localhost in the value field with your server's IP address. There are several of these. You used to have to save this file to persist the changes, but it seems that Postman now automatically saves updates after you make them. Maybe just throw a Control-S in there to be sure. Switch to the Collections tab. Here, make sure your Tazama Docker Compose environment is selected in the top right dropdown. First, let's run the end-to-end test. Expand the 2.1 test collection. Inside, you'll see 3 folders. Expand the top folder called Message Creation. This set of tests will create a set of randomized test messages and send these into Tazama via the transaction monitoring service one at a time. First, we click to run the Create Messages in Memory test. Click the Send button here. You should see a response here at the bottom that indicates that the TMSA PI is up. Then we send in the PAX 008 message, which should then return a success response. And then we send in the PAX 002 trigger message, which should also return a success response. Okay, fingers crossed. Open the second folder called DB Update Tests and click the bottommost test called Fetch evaluation results with message ID from admin service. Click Send. If everything went according to plan, you will see a successful response from the server with all tests passing. Look at that. If you scroll down the response body here, you can actually see the rule evaluation result from Rule 901, which is running on your local machine. Okay, so the end-to-end is working. Now, let's test our rule processor in isolation using the NATS utilities. Open the second 2.2 test collection here. Inside this collection, you'll see two folders, one for Rule 901 and one for Rule 902. Open the Rule 901 folder. The first request is titled Single Transaction Now Successful. Click on it to open it, then click Send. Watch your command prompt where the rule processor is running. Wait, let's put these two windows side by side so we can see what's going on. Let's send the test message again. You should see log messages indicating that it received and processed the transaction. And in Postman, you should see a successful 200 response with the rule evaluation result from the Rule 901 processor. If you see that, congratulations. You've successfully set up your development environment. And your locally running rule processor just evaluated a transaction using the infrastructure on your server. So, what can you do now? Well, you can modify the rule code in Rule 901, rebuild it, restart the rule executor, and immediately test your changes. This tight feedback loop makes development much faster. You also now have command of all the basic building blocks required to build your own rule modules and test them in the Tazama rule executor. We'll cover the development of new rules in detail in an upcoming tutorial as well. Let me mention a couple more useful tools. First, in Tazama, we'd like our developers to practice test-driven development. But at the very least, all code in Tazama must be unit tested with tests written in Jest. We won't cover the test writing itself in this tutorial, but if you want to run the tests that have been written for a processor, you can type npm run test in a repository after installing dependencies and building your processor. In Tazama, we require 95% test coverage for all contributions, and all tests must pass before code can be merged into our dev or main branches. Second, if you want to use VS Code's built-in debugger, create a .vs code folder in your repository root and add a launch.json file. The contents of this file is contained in the developer environment setup guide we've been following in this tutorial, and which is also linked in the video description below. With the launch.json file in place, you can set breakpoints, step through code, and inspect variables just by pressing F5 to run your program inside VS Code. Note that the debugging infrastructure won't be merged into the Tazama source code in GitHub, so you'll have to add it yourself when you clone a Tazama repository. If you run into issues, the best place to get help is our Slack workspace at slack.tazama.org. Ask your questions in the hashtag #GetHelp channel, and our friendly community will assist you. Also, check out our contributing guide on GitHub for more details about the contribution process, coding standards, and how to submit pull requests. We'll add a link to this below the video as well. That's it. You now have a fully functional Tazama development environment. You can develop locally, test against real infrastructure, and contribute to making Tazama better for everyone. Remember, your contributions should be intentional and deliberate. Start by creating a GitHub issue describing what you want to do. Get community feedback, then create your feature branch and start coding. Thank you for joining me in this tutorial, and thank you for starting a journey in contributing to Tazama. Your efforts will help make financial ecosystems everywhere safer and more secure. Happy coding!